Hello students, welcome to Sonu's Learning World. Today we are discussing chapter 3, which is matrix chapter of class 12, and we are going to solve the miscellaneous exercise of this chapter. Okay, so let's read the first question. The first question is, let A is equal to 0, 1, 0, 0. Show that ai plus ba the all raised to n is equal to a raised to n I plus n a raised to n minus 1 ba, where I is the identity matrix of order 2. Okay students, this is a question, and we have studied mathematical induction in class 11, right? We have studied mathematical induction chapter in class 11. So we are using that method to solve this question. Okay students, and this is very easy. So let me explain you how to do this problem. Okay, so what we have to prove? We have to prove ai plus ba the all raised to n is equal to a raised to ni plus n a raised to n minus 1 ba. So that is the thing which I have to prove. So I am going to write here. So this is my answer session, and what I have to prove is ai plus ba the whole raised to n is equal to a raised to n I plus n a raised to n minus 1 ba. So this is a thing to prove. Okay, I have to prove this. So students, this I am writing as p of n. Okay students, so this I am writing as p of n. Let this be p of n. Okay, so next I am going to write some steps. Okay, so step by step we are going to solve this question. Okay students, so the first step is step 1. Okay, in step 1 we are going to find whether this p of n is true for n is equal to 1, which means that we are going to substitute the value of n as 1, and we are going to check whether this side is equal to this side, or this full thing is true, which means that this is equal to this. Okay, so for n is equal to 1. Okay, for n is equal to 1, I am taking the left hand side first. Okay, so LHS. Okay, LHS is what is a sorry students, I hope it is clear. Okay, so this is my left hand side, that is ai plus ba the whole raised to n. Okay, so n is equal to 1. How it will come? ai plus ba the whole raised to 1. Okay, so instead of n I can substitute the 1 here. So this is my LHS. Okay students, and how RHS will come? So I am writing it here. RHS also I am writing it here. So RHS. Okay, so RHS is, this part is my RHS. Okay, so a raised to n I plus n a raised to n minus 1 ba. Okay students, so here I am going to substitute 1, so it will become a raised to 1 is a only, ai plus n is 1, so this will become 1, a raised to n minus 1 is 1 minus 1 ba. So final answer is ai plus a raised to 0 is, any number raised to 0 is 1. So this full term will become 1. This full term will become 1. Okay, so what is remaining? ba is remaining. So this is my answer. So here LHS and RHS both are equal. So I can write here LHS is equal to RHS. Okay, LHS is equal to RHS. So we can write the statement is correct, or the statement is true for n is equal to 1. When we substituted the value of n is equal to 1, we are getting the same. Okay, yeah, we are getting us LHS and RHS same. So we can say this particular statement is true. Therefore, P of n is true for n is equal to 1. Okay, So students, the next step is we are assuming that this particular statement is true for n is equal to k. Okay, we are just taking a random, that is n is equal to k, and we are assuming that this particular statement is correct. Okay, so that is our step 2. Okay, step 2. Assume for n is equal to k. Here n is equal to, n was 1, here n is equal to k. We are assuming p of k is true. Okay students, here it was in terms of n. So here we are, for n is equal to k means it will become p of k. It will be in terms of k. So that's why we are writing p of k. So for n is equal to k, p of k is true. We are assuming. Okay. So how p of k will come? P of k is equal to, or p of k is, what is p of k? ai. So the same thing. ai plus ba the whole raised to what? K. Okay students, instead of n we are writing k. That is equal to a raised to k I plus k a raised to n minus 1. Here it is n minus 1. So it will become k minus 1. A raised to k minus 1 ba. That's it. Okay, so here it has been given that, so we are assuming that this statement is true for n is equal to k. So this is our statement. This is our p of k. Okay, so I am giving this as equation number 1. Okay students, so this is equation number 1. So the next one is step 3. In step 3, what we are going to do is, step 3, we are going to prove this particular statement is true for p of k plus 1. Okay, so to prove, okay, p of k plus 1 is true. Okay students, so we are going to prove that. Okay, so I am going to write everything in terms of p of k plus 1. To p of k plus 1 means, what? Instead of k, we have to write k plus 1, right? So ai plus ba the whole raised to, instead of k, we have to write k plus 1. So k plus 1, okay, that is equal to a raised to k plus 1 I plus, here instead of k, k plus 1, again k plus 1. So that is k plus 1, here k, here you have to write k plus 1. Okay, so that is k plus 1 a, here k minus 1. Okay, k minus 1. So here instead of k, we have to write k plus 1, and 1 minus 1 is also here. So minus 1. Okay, so into ba. Okay students, so how it will come? A raised to k plus 1 I plus k plus 1 a raised to 1 and 1 cancel, 1 minus 1 0. So what is remaining? Only k is remaining. ba. Here it is ai plus ba the whole raised to k plus 1. Okay students, so which means that we have to prove this. This is a thing which we have to prove. Okay, we have to prove this is correct. Okay, so to prove the same thing, to prove p of k plus 1 is true. So this is our p of k plus 1. So we have to prove this LHS and RHS. So LHS is equal to RHS. Okay, so from here what I'm going to take is, I'm going to take the LHS. Okay, so this is our LHS. Okay, this is our LHS and this is our RHS. Okay, so I'm going to take the LHS. Okay, what is our LHS? Our LHS is ai plus ba the whole raised to k plus 1. Okay students, so this is our LHS. Now I am going to split this one. Okay, students, how can I split this one? Can I write like this? AI plus BA the whole raised to K into AI plus BA the whole raised to 1. Can I write like this? Yes. Why? Why I can write like this, students? For example, A raised to K into A raised to 1 is what? A raised to K plus 1. We know X raised to M into X raised to N is always X raised to M plus N. So A raised to K into A raised to 1 is A raised to K plus 1. So A raised to K plus 1 can be written as A raised to K into A raised to 1. Like that, instead of K plus 1, we are taking this term AI plus BA the whole raised to K into AI plus BA the whole raised to 1. So students, here instead of AI plus BA the whole raised to K, in equation from equation number 1, AI plus BA the whole raised to K is equal to this one, A raised to K I plus K A raised to K minus 1 BA. So instead of AI plus BA the whole raised to K, we can substitute this particular value. So let us substitute this value. So here we can write A raised to K I plus K A raised to K minus 1 BA. Okay, so into this particular term, that is AI plus BA the whole raised to 1, that is AI plus BA only. Okay, so next we are going to multiply these two terms. Okay, so let us multiply these two terms. I am going to multiply this term with this term. So A raised to K I into AI. So AI is here. So A raised to K I into AI. Okay. So next one is plus this particular term into the next term. That is A raised to K I into BA. Okay. Next is this particular term into first term. Okay. So that is K A raised to K minus 1 BA into AI plus this term K A raised to K minus 1 K A raised to K minus 1 BA into BA. So next let us arrange the terms. Okay students. So here it is A raised to K into A. A raised to K into A raised to 1 is A raised to K plus 1. So it is A raised to K plus 1. Okay students. What is I into I? I into I is I square. I square is equal to I only. Okay students. So if we know I is 1 0 0 1. Okay. So this is I. I square means I into I. I am multiplying one more time this 1 0 0 1. Okay. So here what is my answer? This 1 into this into first this row into this column. So 1 into 1 plus 0 into 0. Okay. Next term. This into the second column 1 into 0 plus 0 into 1. Okay, so next is the second row and first column 0 into 1 plus 1 into 0. Next is second row and second column 0 into 0 plus 1 into 1. So this is a matrix which we are getting. So this is 1. Here it is 1 and this is 0. This is also equal to 0 and this is equal to 1. So if we are multiplying I and I, we get I only. Okay. So I square is equal to I. So instead of I square, we can write I. Okay. So next plus this term A raised to K I into BA plus here A raised to K minus 1 and A raised to 1 is there. I am writing this first term is K. So next is A raised to K minus 1 plus 1. That is K minus 1 plus 1 minus 1 and plus 1 get cancelled. So A raised to K will be the remaining term. Okay. So that into B is there and capital letter A is also there. Okay. This I is also there. Okay. Plus what is remaining here? K, A raised to K minus 1, B, here A into A is, oh, here two B's are B into B, B square, and here A into A is A square is also there. Okay, students. So, in the question it has been given that the matrix A is equal to, in the question you can see the matrix A is what? Matrix A is equal to 0, 1, 0, 0. Okay. So, this is our matrix A which is given in the question. Students, what is A square? Here we are getting an A square. In this term we are getting A square. So, if you multiply A square, if you multiply A into A, 0, 1, 0, 0 into 0, 1, 0, 0, your answer is 0, 0, 0, 0. You are getting a 0 matrix, which means that this full term is equal to 0 because there is an A square multiplied with the other term. So, this full term is equal to 0. Okay. So, next we can write A raised to K plus 1I. Our first term I am writing again plus. So, from the remaining two terms we can take something common, students. So, what I can take common? A raised to K is common here, and here A raised to K is common. So, this I is common here, and here I is also here, in this also I is there. So, BA is also here, here also BA is here. Okay. So, what can we take as common? We can take A raised to K, B, A, I. Okay. So, what is remaining here? We took every full term from this particular term. So, what is remaining? 1 is remaining. 1 plus, here what is remaining? Only K is remaining, and this term is equal to 0. Okay. So, this is the final term which we are getting. Okay, students. So, into K plus 1. So, here we have to, what was our, this is our LHS. Okay, what was our RHS? Let us check whether this LHS is equal to RHS. If this LHS is equal to RHS, then we can tell this particular assumption is correct, or P of K plus 1 is also true. So, students, this was our LHS and this was our RHS. We solved this LHS and this was our RHS. So, students, let us compare these two. This is A raised to K plus 1 I. Okay, this is also A raised to K plus 1 I. This is K plus 1, that is 1 plus K into A raised to K BA. Here one I is extra. If you are multiplying I with this term, nothing will change. Okay, if you are not writing this I also, your answer is correct. So, we can say that both the LHS and RHS are equal, and so we can say this is equal to RH. Yes. Therefore, P of K plus 1 is true. Therefore, P of K plus 1 is true. That's it. Okay, students. So, students, if you like my videos, please like, share and subscribe my channel. Thank you.